Hello everyone. Welcome to Simply the Best. Let's quickly discuss what we are going to cover today. So this is the agenda for today. Um, I'll start with abstraction in Java. What is the abstraction? Why we need them? What is the way to achieve them? So let's quickly see what is the abstraction in Java. So as you can see, abstraction in Java is a core principle of object-oriented programming that focuses on simplifying complex systems by hiding unnecessary implementation details and exposing only essential information. It allows developers to work with objects at a higher level, concatenating on what objects does rather than how it achieves its how it achieves its functionality. Basically, Java achieves abstraction through abstract classes and interfaces. Abstract classes cannot be instances and may contain abstract methods. Abstract methods without implementation that must be implemented by their subclasses. So, interfaces define a contract for classes, specifying method that implementing classes must provide. So basically, Java achieve this abstraction using two ways. One is the abstract classes, another one is the interfaces. Okay, what is the abstract class? Basically, abstract class can contain multiple one or more zero or more I should say abstract methods, and the implementing class should define the body of those abstract methods. So by default, so as you can see, this is a public abstract void say hello method. This is abstract method because it uses abstract keyword. If if a class contains at least one abstract method, then a class has to be made abstract. If it contains at least one abstract method, then we have to make the class as abstract. But vice versa is not true. An abstract class can contain abstract method or cannot. It depends. So we can, if class has multiple concrete method, even though we can make the class as abstract. Okay. So this is about these 2 points. This is about abstract method and concrete method. So in abstract class, there may not be a abstract method. That's all right. Now, an abstract class in a Java serves as a blueprint for other classes, okay, defining common behavior while allowing subclasses to provide a specific implementations. It cannot be instantiated directly and make contain abstract methods without implementation, and concrete methods with implementation. An abstract keyword is used to declare an abstract class. Subclasses or an abstract class must either implement all the abstract methods or declare abstract themselves. Okay, so let's see an example of an abstract class. Before that, object of abstract class and interface cannot be created, only reference can be created. This is the important thing. We cannot create an object of abstract class or interface, even though we can create a reference of that to perform a runtime polymorphism. I mean, this is one of the ways to achieve a runtime yeah. So as you can see, this is abstract class shape. It has a property called color, which is a data member, normal data member with default specifier. Now we have a shape method. We have abstract method with no implementation. This is a abstract method which is called getArea. Now we have concrete method which is a color. Again we are assigning the color from this property. That's fine. Now this circle class extend shape, which has a inbuilt property called radius, and the method called circle, which is getting the color from the super class super dot color, and for the color it's calling the constructor of the superclass to assign the value of color. Okay, here, and then this radius assigning with respect to circle, and this parameterized constructor of the circle class itself. Okay, we come to override part, double get area. So this is about calculating the area, which is math.pi radius into radius. That's fine. Now we come down to the main class. So now we are creating the object of a shape class. So we cannot create the object of a shape class as it is a abstract class. So the compiler cannot instantiate the type of a shape. That's fine. Shape new circle pink 6. This is valid. We can create a object of a subclass and point it to the reference of the abstract class. This is valid. We can pass this. But let's move on. Just a second. This line I have added just for explaining. Okay, so now we are creating a circle object, and reference is also circle type. We are passing blue and 5. Now we are calculating the area. So now we are calling circle dot get area. So basically this is a circle is a object. On top of it we are calling get area. It will call this get area method, and it will calculate the area. Basically it will apply the radius square on top of so output you will get something like this if you'll pass 5. So in this line what happens, it will call this constructor, it will call the parent class constructor, assign the color and radius accordingly. Now we are calling the get color of the circle on top of circle object. But here as you can see we do not have any get color method, so it will call the get color method of a abstract class shape, which is a concrete method, and fetch the color. So now the color is blue, which we have assigned using this constructor. So this is about abstract class. Now so abstraction in Java we can achieve using abstract classes and interfaces. Now let's see what are the interfaces. Okay, interfaces in Java. So basically interface is provides a blueprint for an object. Classes provides a blueprint for object. Interface provides a blueprint for classes. There can be four type of four features of interface basically. One, it provides abstract method. Second is it provides static constants. What are those, we'll see. And the third is static method, and fourth is default method. So these are the four features of the interface. Okay. Again it supports a multiple inheritance and abstraction. So now let me come down to here. Okay, Java interface. In Java, an interface is a reference type similar to a class that is used to define a contract or a set of abstract methods that a class must implement. It provides a way to achieve abstraction and supports multiple inheritance like behavior in Java. Since a class can implement multiple interface are key feature for object-oriented programming in Java and widely used for designing flexible and modular code. Here is a breakdown of interfaces in Java. So key characteristics of interface: abstract by default. It is abstract by default, no instance variable, multiple it supports multiple inheritance and implementation. A class that implements an interface must provide their concrete implementation for all the abstract methods, and it must declare as an abstract itself. Okay. Okay, now coming back to the interface, let's see the example. So basically here we are creating interface name with interface keyword, and we are defining this constant. By default it is a public, static and final. Any variable data variable in interface is by default public, static and final. Here this is a by default, it is this method is a public abstract, implicitly public and abstract. Yeah. So now default method with implement. So this is a default method with implementation. Default method system.out.println, and this is a default method. Now Java 8 plus static method. Static method system.out.println, this is a static method. That's fine. So okay, so Java support default method and static method as part of the interface, as you can see. So this is the abstract method, this is the default method, this is the static method. We'll see how we can call these method and what are the things we have to perform. So basically for the abstract method we have to implement it. For the default method we can call it by the object, and for the static method we can call it by the interface name, like just like class dot method name, interface dot method name. Now this class, this interface animal, which is provides one abstract method which is void, and another abstract method which is called sleep. Now the default void breathe, this is a default method for breathing of the animal, and the this feature provided by Java 8 Plus only for default and for the static as well. Now the dog class implements the animal class, and it provides the eat method, which is now dog is eating, and here again one method which is called sleep. So as you can see, these eat and sleep method which is coming from the animal interface. So now if a dog implements animal, it has to override those two methods. So we can put override or annotation as well, but that's fine. Now public class, so we come down to the main class. We are creating object of a dog class. We are calling eat, sleep and breathe. Now the breathe will since there is no implementation for breathe in the child class, again is breathe is a default method in the interface itself, so it will call the breathe method in the interface. Now let me see the evolution. Let's see the evolution of, okay, let me go to the slide and let's see what we have next. So we cover abstract classes, interfaces. Now let's talk about these points. Evaluation of interface after Java 8, rules and features, use cases, functional interface. This is a very important thing, and categories of functional interface. Okay. So now evaluation of interface. Pre-Java interfaces could only contain abstract methods and constants. Default method allow interfaces to have multiple to have methods with implementation marked with the, so basically period to Java interface could only contain abstract method and constant, but now after Java it can contain default method, static method, and Java 9 plus added support for private methods, private method for interfaces as well, which for helper classes. Okay, rules and features. Let's see. Access modifier fields, no constructor, marker interface. All the methods should be public, fields should be public, static and final. No constructor, interface cannot be instantiated and cannot be create constructor. Marker interface, this is an important thing. Interface which has no method. So what are they are in Java, they are like serializable, clonable. Marker interface in Java is an empty interface, means having no field or method. Examples of marker interface are serializable, clonable, or and a remote interface. All these interfaces are empty interfaces. Now okay, example with multiple interface. um, let's see how we can achieve this is multiple interface. I think it's multiple interface. See, this is flyable, this is swimmable. Class duck implements flyable. Okay, so the class duck implements both interfaces, and now it implements both method fly and swim. And in the main method we are creating object of a duck, which is our class duck here, and we are calling the fly in duck. So this is the way of to achieve multiple inheritance using the interface. Right? Yes. Use cases, abstraction, API design, loose coupling. What is the use cases of interface? Defines the contract without worrying about the implementation details. API design, widely used for a framework like List, Map, Java, Clash framework. Loose coupling promotes modular design by allowing classes to interact with the interfaces rather than concrete implementation. Function interface, what are those? Function interface as an interface are with exactly one abstract method. This is important thing. In a function interface, it must contain only one abstract method. They are used, so they can contain a default and static method as well, but abstract method should be only one. They are used with the lambda expressions with the Java Stream APIs introduced in Java 8, example as runnable and clonable. So this is a function interface. Since this is a one, it contains only one abstract method, we can use the function interface annotation here as well. Now in the public class main, public static void main string RGS, we are uh, basically what we are doing, we are creating a first lambda expression for this perform operation. So what we are doing, we are taking the parameter and we are writing as part of lambda expression println and assigning it to the my function function, which is a type of my function reference, which is a type, which is again interface. Now on top of function we are calling that particular method, so it will print the performed as output. This is a tricky thing. As you can see, this is the interface ABC, and it has a method public static void main string args. Since in an interface, method can have the public static void main. So this is a one of a static method interface, which is a feature introduced by Java 8 plus, and this is a valid syntax, and it will print the hello world in the output console. So this will run. So now we can run our Java program with the interface as well. That's right. Java function interface, what are those? Let's see. This is the important thing, guys. um, uh, A function interface in Java is an interface that contains only one abstract method. Function interfaces can have multiple default or static methods, but one abstract method. A runnable, action listener, and comparator are the common example of Java function interfaces. From Java 8 onwards, lambda expressions and method reference can be used to represent an instance of function interface. Using the function interface with lambda expression. Okay, we have seen this. We have pretty much covered everything. Let's see example of function interface using lambda expression. So basically, here what we are doing, we are creating a new thread object, and we are using a lambda expression set to a new thread. On top of we are calling the thread dot start. So it will create a new thread as part of the output. It will print. Now, function interface annotation, define the function interface interface square, geeks for geeks, this is fine. We are creating one variable int a, and we are this is the lambda expression. Basically what we are passing int x, because it takes int x. You can avoid x, you can just pass x here as well, right? X into x. Okay, now we have to define it. Okay, as you can see, guys, let me move down to the built-in function interface. So Java 1.8 onward, there are many interfaces that are converted into function interface. All these interfaces are converted with that function interface. These interfaces are as follows: runnable, comparable, action listener, and callable. Okay. Categories of function interface. So basically we have consumer type, supplier type, function type, predicate type, operator type. Accept input but do not return the result. This is the consumer type. So let's see. This is a predicate boolean result. So basically it is one of the interface which is available on java.util.function package. So basically, as you can see, this is the predicate class. It has only one function called test, which returns boolean. Okay, now we are here, and we are we are creating a lambda expression. Let me zoom it in. So we are creating a lambda expression which should count the length. If it's greater than 5, it will return the boolean, otherwise true, otherwise false. So here we are passing the string check length, which is greater than 5, the output is true. So what is the syntax? Check length dot test, because it contains the test method. This is a predicate class. Okay, now we are passing the length, which is 4, so it will return false because it's lesser than 5. Consumer modified data no input. So basically we have a consumer class which has a method which is accept. It prints no output. Okay, so how we can use it? Basically here we are having person, and basically it's a name, one of the field, data variable, and data member we can say, and this public string get name. So we are getting the name by calling the get name, and we have the set name as well. So we are setting the name and getting the name. That's fine. And in the main class, person p new person, consumer person set name t dot set name. Okay. So here what we are doing, we are setting the name t dot set name play Java. So we are creating a person object. That's fine. We are setting the name play Java, and we are using this consumer class of type person. Now the accept, we are calling the set name accept, and we are passing this p. What is this p? Which the p is the object. So now we are calling the p dot get name. It will print the name of the object what what we have set earlier. So we are using this particular the interface, functional interface, to perform the set name operation, right? Set name dot accept p. Now function, both input and output. So this is a one of the functional interface called functional. It has a functional interface. Basically all those are interface only, not a class. Okay, yeah. So function, it has a apply method in it. It takes 2 argument. Okay, let's see what are those. And apply takes 1 argument and return something. So as you can see, this is the main class, and we have integer and string. So input to be passed, this is the integer, and output to be written, this is it returns the output r. So yeah. So now we are passing. So this is we are performing lambda expression get int. This is when we are assigning on get int t. We are passing this t and performing operation t into 10, and then concatenating with the string data multiplied by 10. Now in the system.println we are passing get int dot apply, which is apply this method, and we are passing 2. So it will print, it will multiply by 2, 20 data multiplied by 2. Now let's see the supplier only output. So this is the one of the interface supplier. It has a get method. So as you can see, we are first creating the reference of the supplier, double, and we are just performing the lambda expression mat.random here. So what it does, only it will print only output. So now on this reference we are calling the get, and it will print, it will take no input. Here the output will be random double. Okay. So guys, we have come to the end of our session, and this is about all about abstraction in Java, abstract classes, interfaces, and the key features of interfaces, how it evolves after Java 8, what are the rules, use cases, the function interfaces, types of function interfaces. We have seen everything. So thanks for your time guys. Bye bye.